Assalamu alaikum. My name is Abdur Rahman and my roll number is 16T22. In today's lecture, we will study the Z transform. So let's start. For time sampling, x of z is equal to summation of n is equal to minus infinity to plus infinity and x of n into z of minus n, where z is the complex variable, and it is equal to Z transform is equivalent to Laplace transform in continuous domain. As n increases, so does the power of z, and the simple notation is x of n is represented in Z transform as capital X of z. We see an example x1 is equal to 1 2 5 7 0 1. So we transform it into Z transform by using the formula. So we obtain a capital X of z is equal to 1 plus 2 into z raised to power minus 1, 5 into x z raised to power minus 2 plus 7 into z raised to power minus 3, and we have 0, so we will not represent it, and z is into minus raised to power minus 5. So we put the value z is equal to 0, we get infinity. So our region of convergence will be entire plane except the value where z is equal to 0. Another example is seen. So we will calculate the ROC there. So put the value of 0, so we get entire value except 0, that is we place the put the value z is equal to 0, so our whole function becomes infinity. So our ROC is the whole plane entire the value where z is equal to 0. So we represent signal lambda delta of n minus k. So the Z transform is z in raised to r minus k. So the value for this case, the ROC is whole except the same is the case for that is we put 0, so we get infinity. So ROC is all the values except where z is equal to 0. And then in the next case we have a delta into n plus k, where we put 0, we get a finite value. So we put infinity, z is equal to infinity, so we get infinity. So the region of convergence is all the values except where z is equal to infinity. So here we will discuss a causal system, that is x of n is equal to a of n into u of n, where a of n is the value when n is greater than 0 and 0 is the value when n is less than 0. So we take the Z transform to get the value x of z is equal to minus infinity to plus infinity in summation a of n into u of n into 0 raised to power minus n. So by rearranging, that is we have u of n, so we can change the limits into 0 to infinity, and we can shift the power outside, so we get a into z of minus 1 whole raised to power n. So as we know that summation of using geometric series, we know that summation of 0 to infinity of a of n, we get value 1 over 1 minus a. So for a less than 1, the given value of a less than, this equation is only valid when some mod of a is less than 1. So same we apply this in this formula to get 1 over 1 minus a into z minus 1. So we equate this value should be less than 1, so we get a is less than z. So it means whenever our a will be less than z, our ROC will be outside the unit circle, that is shown in this figure. And similarly we if we simplify our equation, we get z over z minus a. In the next example we see a non-causal system, that is our previous values are also in this form. So x of n is equal to minus a raised to power n, u of minus n minus 1. So a of n is when n is less than 0, the case is reversed, and 0 is the value when n is greater than or equal to 0. Take the Z transform, we obtain this value. Similarly by changing the limits, we get the values minus into summation minus 1 to minus infinity a of n into z of n. Similarly by resolving these, we get the value 1 minus summation 0 to infinity a raised to power minus 1 into z n, and using the geometric series we have obtained this. So whenever we substitute this value to 1, we get the value z is less than a. So in this case our ROC will be inside the unit circle. So we see general example, that is x of n is equal to 1 over 2 raised to power n u of n plus minus 1 over 3 n u of n into u of n. So we calculate separately. Z transform is shown in this part, and the transform of this part is shown in separately. So we calculate the ROC using the observed value. So ROC for 1 by 2 is represented by this, and outside this function, and 1 by 3 is represented by this. So we take the intersection, that is the ROC that is common between both of these. So final ROC is represented by 1 by 2, the region outside the pole of 1 by 2. Similarly, if we have value u is shifted, that is u of minus n minus 1 and u of 1. So in this case, our region will be inside the circle, and in this case our region will be outside the circle. As this value is smaller, this is greater value, so we obtain a ring like structure. So in this topic we will see how to plot our frequency response if we are given the pole zero representation in this form. So we see the formula h of z is equal to y of z over x of z, where y of n is equal to y of n plus a1 into y of n minus 1. This whole term is represented in y, that is our output, and this side is represent our input. So we take the z transform, and by rearranging we get the value h of z is equal to y of z over x of z is equal to b naught plus b1 into z raised to z of minus 1 plus b2 into z of minus 2, that how many poles we have, and how many zeros we have. And similarly in the denominator we have pole that is represented by 1 plus a1 z raised to power minus 1 plus a2 z raised to power minus 2 till an z raised to power minus m. So let we have h of z is equal to z over z minus 0.8. So in the denominator, to calculate the value of the frequency response at different angles, and in the numerator we calculate the length of all the zeros, that is the if we have two zeros we calculate both of their length from that angle and multiply them. And similarly in the denominator we calculate the length of poles at that specific angle, and we multiply them in order to get our response at that angle.